Good morning, everyone. Let's get started here, 9:10. Okay, so today our goal is to finalize our yield editor exercise. We almost did that last time. I think we're just needing to go through some more of the map, creating some maps to explore the results and compare them. And once we finish that, we're going to start with an interpolation exercise that I did share the partial script last night through GitHub. So I'm pretty confident we're going to start that today. So please make sure you already have that script on your code folder of the 04 yield monitor project. All right, so you're seeing my screen here. So as always, we're always starting. I always like to show you, how things are starting as far as like launching the project. So let's go ahead. If you have not done yet, just go ahead and launch that project. And again, just to remind you, again, if you come on code and you click on code and launch it that way, it will open an RStudio environment. Maybe that is your project already, but maybe it's not. So always to make sure that you are opening the proper project, I do recommend that you double click on the rproj icon instead of the script icon, because that makes sure that you're opening the right project. Okay, let's see here. Yeah, so mine is popping up. Here's where we stopped last time. So if we, again, check on our outline, we just have to finish doing some of the maps and then exporting the clean data version after that point. So as you can see on my environment right now is empty. Probably yours is too. And so I would recommend for us to just run all above up until this point here. So if you come on the maps on your outline here, you come on maps and go on the chunk right below it and then say run all above. It should start running everything up until this point. And if you don't have any lingering errors or mistakes or uncommented installed packages before, but if you didn't leave any of those things above, it should run through very nicely up until this point. And we can follow here on the progress bar to see whenever it's done. So on my side, it ran all right. If on your side, for some reason, it didn't, so a good way to know if it ran all right is you should have, so the latest data set that we have created through this point is the EO17 WPF for position filter. So if you were to create this plot here that is right above the last thing we did, if it doesn't run because it says this object doesn't exist, then something happened when you were running all above. Okay, so assuming that everyone was able to get to this point, let's start with some maps. So if you remember looking up here, we were comparing basically using the summary functions to see like how the clean or how the raw and clean data versions compared. We combined both of those results using the bind rows to see them side by side. So we saw here how the number of observations changed from raw to clean, the minimum, the mean, maximum, standard deviation, and coefficient of variation. So we talked a little bit about that. And then we made a plot of the distribution of yield data, comparing again both the raw and the clean version. And one thing we noticed was that the raw data had a lot more values around 0 or very low values of yield that were removed, probably by the minimum yield filter. And the clean version, which is the yellow one here, doesn't have as many very low yielding data points, and it has a higher peak because now we concentrate more data points around the mean once you start removing the tails. That's why it has a more concentrated peak here with the yellow density plot here. Okay, so the first thing that I asked you to do was just, you can just go ahead and run this first chunk here. That is really just plotting for us the raw yield map. And again, we know, if you recall in the beginning of the script, we created a ggplot that produced this plot here, and we saved that ggplot to an object. So that's why we can basically just call that object here and it prints the ggplot for us already. So we don't have to repeat the same code or copy and paste the same code. That's why it works like that. And again, we know this is the raw. I mean, first because we created it as being the raw, but also if you look at the, just to double check that we got it right, you can see on the colors scale here of yield in pounds per acre, we still have that very high yield point that is like above 4,000, right? And we know that was on the raw file or the raw plots, raw data. Sorry. Okay, so if you come down to the next chunk here, we have, so I basically left you the code, but we're basically doing the same thing as above, right? So when we created the yield map underscore raw, we're doing the same thing, but saving the result to an object called yield map underscore clean. And the only difference from the above is that instead of having the yield 17W, which was the raw version, now we have the yield 17WPF, which is the position filter version, which received all the incremental filters, including minimum maximum yield, minimum maximum speed or velocity, and position. So please go ahead and run it. So this is our clean version, right? So we see that first, we see a lot more detail, as we already noticed in the previous plot. The range of the colors here is more confined to a range that makes more sense. Notice how we have gaps, right? So all of these were points, right? This is not a raster, this is a point vector file. So all the points that were left out when we apply the filters, those points were basically removed from the data set. And that's why we see some of these gaps here, right? So even though, this has been, up until this point, it has been a point vector type of object all the way through. So it's not a continuous coverage type of data. It's not raster, it's a vector. But still now we can actually see some of the gaps a little bit easier from this zoom level because those were the points that we removed data. Okay, so if you come, someone has a question?
Yes. Like when you look on the scale, yeah, it indicates like we have 4 levels of yield, right? And 1 color on the bottom. Is it because maybe it's just indicating the ground or?
Sorry, so you said about the scale.
If you look on the region, yeah. We have 500, 1,000, that one, yeah. But on the bottom of the region, there is nothing.
Oh, you mean like what would be the floor?
Yeah. Is it because of what, plain ground or no feature or what? Because I was thinking like maybe we need like every color to indicate the yield.
Yeah, that's a good question. So if you think of it, the minimum here would basically be the minimum of the data set, which I think for this data set is 200. But because, I mean, and of course, like if we wanted to change the way that this legend looks like, we could do that. There are different ways we can do that. But both, so if you in this, so when we use the scale, so the Viridis B for bend, what it does is it kind of calculates for you the breaks that make more sense based on the data and how many breaks how many classes that would create. So here it decided for us that wanted to apply a color scale that has a different bin at every 500, I guess. Yeah, that's right. 500 pounds per acre increments, right? And really, if you look at this, the 500 is actually not a class, but it's the breakpoint between 2 classes. Meaning that the first class is from the minimum value in the data set up until 500. The second class is from 500 to 1,000 and so on. And the last class is from 2,000 and above. all the way to the floor of the data, or to the ceiling of the data, sorry. Yeah, so it can be a little bit confusing. And again, ggplot has so many ways for you to customize if you wanted a different type of legend. You know, if you wanted to specify different breaks, if you wanted to have saying like from 200 to 500 being the first bin, all that, you can all do that customization in ggplot. But that's a good question just to clarify how those numbers are being interpreted, I guess. Does that help, Dennis?
Yes.
Okay. Yeah, so basically for this data set, what we would do is we have to see what's the minimum of the data, which is around 204, I think. And that would be what the floor here would be. And the ceiling would be basically the maximum of the data, which I think is like 2000 something. Yeah, great question. Thank you. All right, so let's go to the next chunk. I left you, I think, all the code already. Let me just make sure. Yeah, I think I left you all the code already here. So basically what we're doing is starting with our filter version and plugging that into a map view. So this is supposed to be the interactive. So not the animated, not a GIF, but the interactive version where we see on map view, where we're using yield and pounds per acre as the variable that we're giving color based on. We're making the points completely solid. So if you remember, alpha is the way that R, I guess, or programming languages refer to transparency. So we're saying that in that value ranges from 0 to 1, 0 completely transparent, 1 completely solid. So we're asking for that to be completely solid. We're decreasing the size of the point so we can see better. With the LWD, we're just removing the outline of the point so we don't see that like whole bunch of dark points. And then finally changing the base map to an Esri world imagery, which is a satellite imagery. So if you run that, sorry, I think I'm hearing a little bit of echo from Athens. So I'm gonna mute, Amrinder, I'm gonna mute you for now, but if you guys have a question there, please feel free to just unmute yourself, but I'm gonna mute you for now. Okay, so if you just ran that chunk, this is what you should be seeing now. Again, this is an interactive map, so you can really zoom in, zoom out. You can turn on and off that layer to see. And here's something very interesting for us to notice, right? So, I mean, we know kind of where some of the filters were applied. And perhaps hear that conversation as far as like, you know, am I removing an actually low or high yield point, or am I removing something that was definitely an error? You know, again, the only way to really ground truth and make sure of that is if you go and take samples yourself, or maybe you do some type of data collection on the field to back up what you're seeing on the map. We don't have that type of data here, right? We do, like, no one, at least that I know of, no one went out and collected samples to make sure that what we're removing is actually error and not a truly low yield. So we're not going to be able to double check that. But just to show you here, right, so we see that lots of points were removed around those eroded areas. There's still some low yielding points around the eroded areas, right? You can still see them, but not as many as before because we removed some of them, probably on the minimum yield filter. And again, did we remove true low yielding data points, or did we remove erroneous low yielding data points? I don't know. But it's just for us to keep that in the back of our heads. And also something interesting here, and I guess some of you did get this on the quiz, is if you see, you also removed that area right there, right? There's these data points around this area. And this area here was actually, if I remember correctly from when Dr. Velides was telling me, this was an area that accumulated water and was like waterlogged, which basically, you know, plant roots need to respire, need to breathe. And if you have waterlogged conditions, they cannot. So the plants basically die if it's for a prolonged period of time that they're waterlogged. And I think that's what happened here. So in that case, this area here maybe should not have been removed. Maybe these were actually low yielding data points, even though our filters removed them. So these are, we're not going to address that. If we wanted to bring back those data points into the data set, we could. We're not going to do that. We're just going to continue. But just for you to think that, or for you to always remember that just because the filter is removing, even though we are using sound principles for removing the data points, it could also be removing true low yielding data points, especially. So just keep that in the back of your head when you're actually doing this, maybe for research or maybe for a producer or for your own farm if you farm. Just a good thing to keep in mind. Okay, so one thing I want to show you a couple ways of comparing two different plots side by side. So one of them is going to be on the excuse me, on the static maps. I basically left you the code already. You can just go ahead and run. And I'm going to tell you in a second what's going on here. So if you run this, we're basically printing side by side the EOMap raw, which again was the ggplot that we created in the beginning of the script, with the EOMap clean, which is also a ggplot that we just created above today. And again, this is a static map, so we cannot zoom in, zoom out, but it just basically puts them side by side. And I just want to tell you how does this work like this? Why isn't it all confused? So this plus here, even though we've used plus within ggplots up until this point, this plus here is here working and putting them side by side because of the package that we loaded in the beginning that is called patchwork. So this is a good, so I'm just gonna say, you don't have to type what I'm typing if you don't want to, because we have already loaded this package. I just wanna do that here so you know why this is working the way it is. This plus here is basically, in this case, is coming from package patchwork, because it sees that you have a ggplot object on one side and a ggplot object on the other side. And then that kind of triggers that this plus here is coming from the package patchwork to combine them. And if you're ever doing plots, like you want to combine multiple different types of plots in the same, view, I guess, especially if you want to export them, I definitely encourage you to take a look at the package patchwork. They have a very nice tutorial on their page. So if you do like package patchwork in R on Google, you will find that. It's a very, very useful package to combining multiple different types of plots, and sometimes some very complicated combinations that, maybe you would do in PowerPoint if you were doing yourself, but there's a way of doing that more programmatically in R if you use the package patchwork. So I just want to bring that up in case any of you need to do that, maybe in this class, but maybe, in your own projects. So we just, have this side-by-side view of each one of the raw and the clean data. Again, it's a nice way for us to compare and see where data points were removed, and how that impacts, I guess here on the map is really how that impacts the color scheme, because then it brings the points closer in that distribution instead of having, from 0 to 4,000. Now we have from, 200 to 2,000. So we're bringing them closer. That makes it easier to visualize the data points, also visualize where we have gaps now because of the data that we removed with the filters. So the last thing I want to show you here is just a nice trick that I learned recently, actually, and I think is really cool. So basically the next goal is to do this, but in an interactive way. I think that perhaps one of the main downsides of using R as a GIS compared to ARC or maybe QGIS or something, or SMS, is that in R you don't have that consistent view of the map right in front of you, right? You have to print it to create that map. Whereas in ArcGIS, for example, you always have the map right in front of you. Even if you're doing things behind the scenes, you always have the map in front of you. So I do want to bring, every time I can, I want to bring the interactivity to you, so we maybe bridge that gap a little bit more between, being able to see a map in R. So if you come to the next chunk here, to do the side-by-side raw versus clean in an interactive way, we're going to use this function called sync. So I think this is coming from a package that we installed in the beginning. I think it was like leaf map sync or something. Yeah, leaf sync. This is the package that this is coming from. So this basically allows us to visualize two map views together side by side. So if you recall, we created an object. I think it was, let's see, I think it was up here. No, it was earlier in the script, so I'm not going to go all the way up. But we created an object called, if you can start typing with me, yield map underscore raw underscore int for interactive. So this was our, if I just come and print this by itself, it was an interactive map of the raw data. I think maybe it wasn't the completely raw. I think we just removed on the fly that really high observation, but everything else besides that is still here. So we still see the boundaries being very low. We still see that area being very low. We still see the eroded areas being very low. So I want to see side by side this map, this interactive map that we already created above, and we saved into this object called yieldMapInt, and add a comma there. And I will also want to see, besides that, another object that we just created above here. This one is closer, so it's easier for me to just come and show you. So we created this interactive map of the clean yield data, right? So, and we saved that to this object called yieldMapCleanInt. So that's what I want to have as the second argument here. So yieldMapRawInt for interactive and yieldMapCleanInt side by side. If you run that, it may take a moment here for that to go, but here we have them interactively, right? So both of the maps side by side. It's kind of cool that, like, if whichever one you have your cursor on, it kind of adds a second cursor to the same map onto the other map, so we can really see. You can zoom in, and they zoom in together. If we're trying to inspect a given area, you can really see them side by side. So if you pan, they pan together. Although sometimes it does this weird thing here where it moves in space, and I'm not sure why it does that. But yeah, I think the main functionality is just for us to be able to see them side by side, zoom in, zoom out, and just do it that way. Yeah, so you can even like turn one off and then have both of them if you for some reason want to see, something like that. So just wanted to show you this interactive way also of seeing both of the raw and clean data. Okay, so we got to the end of it. So we applied, let's see, 5 filters, right? So min and maximum yield, min and maximum speed, and position. We explored to see how our filters applied the statistics of yield of these two data sets. We created some maps to explore them as well. And so now the goal is I want to save so remember, the objects are things that we have inside of R, but they're not files yet, right? They're still objects. So we want to make sure that we export these objects as files so we can bring them in next time that we need them in a future script, right? So to do that, we're going to come here and export the yield17 WPF, which again was the one that had all 5 filters applied. So if you remember, for us to do that, we use the function write_sf. We're using, so, again, the same way with the read functions, the write functions there are lots of them. If you write underscore and you hit tab, there's going to be a whole bunch of them. We're using write_sf because we want to export a geospatial data set, right? Not write CSV, write_sf because geospatial. The first thing that we give it is the object name that we want to save as a file. And again, that's the yield17 _w_pf for positional filter. we add a comma. I'm going to hit return a couple times just to break the code. The second argument is where and what name this file is going to have. So we open and close quotation marks. Again, right now we are inside the code folder. To get outside of it and into the main folder of the project, we do .. If we hit tab, now you are the main folder of the project. Go inside of data, and now we need to give it a name, right? So if we just hit tab, it's going to tell us what's in there, but the name we want to give it is not there yet. So I want to call this yield 17 underscore clean dot geojson, right? So the name is something that we're giving it, yield 17 underscore clean, and we have to add the extension there as well. So that is .geojson, right? Always remember that. So we could just do this and stop here, but if you recall from a previous class, we talked about adding a third argument here. So add a comma, hit return, and the third argument is delete underscore DSN. So I know that when you're typing delete, it pops up a delete layer. That's not what we want. We want delete underscore DSN. We want to change that to true. So this doesn't append. If you run this twice without the delete DSN equals true, it will append. So basically combine the same data set twice in the same file, which is not what we want. We want to overwrite. So instead of having the two copies, it's just one. So we have delete equals or delete DSN equals true. So if you run this, and then if you come here on your files, click on the blue button to take you to the main folder, go inside of data, you should have now a EO17 clean.geojson right there. Okay, so just a quick summary here. Again, we finished today learning and implementing 5 different yield filters. On the original paper, there were more. I believe there were 12. We did not implement all of them, just some of them, but everything that we did implement here was based on the paper. So we used the same values that they were proposing, the same type of filters. So we did follow that paper on the filters that we applied. And then we, compared the raw and clean yield data, again, with tables, with plots and maps, including interactive maps. Okay, so this is it for this exercise. You can please go ahead and click on the save button on your script just to make sure you have that copy. I will be posting later today the complete version of this script in case you missed something, but we're done with this. I just want to open the floor to see if anyone has any questions or maybe issues that you have in relation to this exercise here.
Dr. Bastos?
Yes.
On the side-by-side raw versus clean yield map interactive, I've got everything right and I'm running it and it comes up like the two side by side, but everything's grayed out like it hadn't loaded, and I've reran everything and it would not load in. Like everything up to that point will load. The side by side raw versus clean yield map, it'll load, but the interactive and or those two, it won't load.
So one way to troubleshoot that is, so here we're combining 2 objects, right?
Yes, sir.
So my guess is that maybe when you created one of these 2 objects, maybe something happened up there. So what I would recommend is if you just take one of the objects at a time and print only that object and see if that object by itself comes out properly. So like I did here for the first one, the raw, I'm going to do again for the clean. Because when you print them up by themselves, if there is something wrong when you're syncing them, that something is going to pop up when you do them by themselves.
And maybe my interactive one, because it's still grayed out. I haven't tried my clean interactive yet.
So your clean one is the one that's giving you the
I haven't ran my clean yet individually. I just ran the raw and it's just same thing. It's not loading.
Okay, interesting. Yeah, I would do. So, go ahead.
But previously, like in chunks, it must be my raw because my clean ran just fine by itself.
Yeah.
I
So
recommend that.
the raw one we created very early in the script. I think it was like, yeah, so it's under EDA raw map interactive if you have your outline open.
Yes,
So
sir.
click on that, it's going to take you up there. Maybe there's something like here if you can, check your code and compare with mine. Um, I'll leave it up for a moment, and while you do check on your side, I just want to say something to everyone before we move to the next exercise. So I just want to remind or bring up a few reminders about the mini project. So the mini project is due this Friday at 11:59 p.m. I know a lot of you have already done a lot of progress on it. One question that came up a couple times is, as in class, like when we're doing the script, we do print the data sets, and those data sets are normally large, right? Some of you may have larger data sets than others, but still, regardless, it's still going to be more than 10 rows, let's say, for everyone, which is already, gets cluttered when you create the HTML to have to scroll through 6,000 rows of data. So one way to avoid that, at least on the, I mean, when you're doing the analysis, you're on your side, and if you do want to see the whole data, that's completely fine. But when you're getting things ready to render, to send me, right? So remember that what you send me are your answers, right? So they should be, like, the file itself should be polished to some extent. You don't want to send me something that I have to scroll through 6,000 rows just to get to the next point. So to avoid that, when you render, you can always use the function. There's a function called head that you just say head data, and then the object of that contains the data. And that function basically only prints, I believe, like the first 6 or 10 rows of a data set. And that helps you to at least, because you're able to print the data, you can still see some of the structure of the data by just printing the initial 10 rows or so, but you don't get things too cluttered, right? It doesn't become like a very long data set. So I just wanted to bring that up to everyone. So we have that you can do that when you're rendering before you submit to me. Also, another thing I want to mention about the project is if you're having issues still creating the animated map, so the GIF one, right? And I know some people are able to create the animated map in the script. However, when they render, the animated map is not appearing on the HTML. If that is your case, I still want you to create the animated map, even if it doesn't appear in your HTML. If that is your case, if it's not appearing on your HTML, please go ahead and save that GIF to a file and send me the GIF file as well with your HTML. So I can see your animated GIF and also have your HTML, even if the animation is not appearing on the HTML. And we'll go through in class how to export that GIF to file. So if you go back to your code or maybe to that recording, you will be able to find that. Okay, Miller, were you able to find out the culprit?
Yes, sir. I don't know what it was, but it works somehow. Don't know how.
Okay.
Thank you.
Nice. Yeah, sometimes that happens. Like, they say that 90% of computer problems can be fixed by just rebooting things. So this maybe was one of those cases. All right.
I have one question.
Yes.
The yield map that we produce, the static yield map, that is in the projected coordinate system, right?
That's right.
But I think we should have like a x-axis and y-axis in the meters or in the degrees.
So that's a good point. I think that, let me see. So let's just look into that. That's a great point, Shakari. Let me check that. So if we come here on the raw one, so we were using the WPF. I just want to print WPF. So that's really interesting, because if you look at the object that we're using to create the maps, they're actually in the projected CRS. But when we're creating those plots in ggplot is actually adding the coordinates as degrees. So that is really interesting, right? I guess I didn't notice that. Thanks for noticing that and bringing it up. So I think it's just like ggplot on the fly, changing this for us just to make it look on WGS84, even though the incoming object is projected. So it is in UTM. Yeah, that's a great point. Yep. So I think we should be good to export it this way. It's already in the CRS we needed, and ggplot is just being, smart, I guess, about.
I have a small question.
Yes, go ahead, Dennis.
Yeah, the function for saving the interactive map, is it different from saving the animated map? Because I just use like saving the interactive map, but I go to the animated map.
So the way it works, the thing is like, so the interactive map, so the one that we zoom in and out, at least that I know of, there's no good way for us to export it. Like the way to export an interactive map is gonna have to be through an HTML file, right? So it's not gonna be by itself, it's gonna be embedded into the HTML as far as the interactive. For the static and the animated, right? So static would be using the function ggsave, right? In the animated, I believe it was gifsave, even though maybe I don't have the proper package loaded. But if we go back to that lecture, we did use a function that I think was called gifsave or something like that to save the interactive, or sorry, the animated. The thing is, both with ggsave and with gifsave is, so let's say if I had here, let's say if I wanted to export this, right? Let's say, oh, I do want to have a PNG file that shows this. I would say ggsave. I'm just going to do that quickly here just to give an example. So back / I go into output. I want to call this yield 17 comparison.png. So if I run this, it will save, right? So if I come to my output, it is there now. And if I click on it, okay, this is exactly what I was trying to show. So what happens is if I click on it, it didn't save the map I wanted it to save, or at least I thought it was saved, right? This is not it. This is just the raw by itself. So what happens is both ggsave and gifsave, they basically save the last plot that you ran, regardless what it was. So if the last plot that I ran is actually something else, I think it was this one, the last one that I ran. So if I run this, right? So this is the last one that R knows I ran. And even though I go to a different chunk, if I don't run this plot here again before I run the ggsave is just gonna print the last one that was printed. So if I do not run this to actually print the plots before I run ggsave is just going to print the latest printed map, which was not the one that I want to, right? So I do have to come here and run the the side-by-side one, and then run ggsave, and then now is going to actually export or save to file the two side-by-side. So if you're using ggsave or gifsave and it's not saving the proper map, is because you probably ran another map and then came back to ggsave. So I would just say go ahead and print again the map you do want to export and then call ggsave after that. Does that help?
Yes, my problem was printing the interactive map.
You mean just printing like on the script like this?
Yeah, like the one you can to print that one. Yeah, like if I want to print that and still it is interactive, like a GIF map.
At least like when I refer to print, I mean like right below the chunk. So are you saying that, or are you saying to
Yeah,
export?
yeah, like that one. I don't know. Yeah, to make it like itself.
Yes, yeah. So the interactive map, the only way to export it is through HTML.
Okay.
I mean, you could have an HTML that basically only has this plot, right? If you create a new QMD file and you just delete everything else, just run the chunks needed to get to this point and then print this, you can do that. Yeah, but because it is interactive, I don't think there is a file type that lets you export an interactive map by itself, right? That's when HTML comes in handy, because HTML gives you that power, I guess, of having something interactive on a file. All right, so any more questions about this exercise or what we did or code? I'm not hearing. Oh,
Can you
yes.
put a title comparison one over like comparing raw and clean data?
Can you repeat your question, Kriti?
Can we put a title on that compare data file that we just exported?
Yes. So that we can. I think maybe the most straightforward way to do that would be to go back to the object that we created, right? So let's say on the EO map raw, I think we created that. Let me just get this up. We created that here, right? So this is where we created the EO raw map and saved to that object name. So I mean, we could come here and really. So right now, these maps, or at least the static ones, are not publication ready, right? This would not go into anything as is. We would still have to do some polishing. So let's say if we did want to add a title, we could just come here, add a plus, use the function labs. Inside the labs, there is an argument called title, and we could say, give it an informative title. So let's say yield monitor raw data for 2017 or something like that. So if we run this and then we print it, now we have the title, right? So basically you can do whatever polishing you want to do at the level that you create the object. And then when you print it, that's just going to follow through, right? So right now, if I went back to the combined, both of them on the static, let's see. Oh, no, it's below here. So now if I print this, the raw one would have a title. The clean one would not have yet because we haven't changed that yet. But that's basically what you would have to do is just like go back to the original one that you created and save to that object, and then change, edit however you want. And then that would show up afterwards. Awesome. Any other questions? All right, I don't hear anything, so I think we can.
Dr. Castro,
Yes, go ahead.
like it's not a problem. Like I just want to add one other function to the map. Like we're printing 10 years of map, and year is changing with as GIF changes. But I want to add a line below the map, which showing like moving from 2011 to 2020, and then as GIF changes, it shows that year by year changing. I search online a lot, but I can't find. So can you just name the function so I can search about that?
So I never try to do that myself, so I wouldn't be able to tell exactly how to do that. Like if I wanted to do, I would have to Google as well. I guess the only pointer I can give you is I would believe that you would have to use the ggAnimate package to do that.
Okay.
Now to add the line, maybe that would just have to be another ggplot that you have a line, like a line plot. Yeah, I can take a look on Google later, and if I come across anything that can give you some help, I'll share that with you later.
Thank you.
Yeah. All right. Any other questions? All right, I don't hear anything. So let's, again, if you want to go ahead and save your script before closing it, you can click on that save icon, close it. And now if you were able to already download what I shared last night. Oh, you know what? No, let me just take one step back here. And yeah, I think we can actually talk about something else before we get into the interpolation exercise, which is the following. I have a assignment for you that is also, I also shared in the, let me bring that up here. So this is already on GitHub since last night, since I sent you the email last night. So if you go on assignments, there's an assignment 5 folder, and I would just want to launch the QMD to show you here what it is. So this assignment here is going to be really important that you do on time, and here's the reason why. So I just brought in so it's a QMD that I share with you. So here's what I want us to do next. So if you think of it, we took that yield 17 raw yield data, and we first wrangled it, and then we applied the yield editor filters to it, and then exported that as the clean version, which then we're going to use next to do the interpolation. However, this is a good stopping point to give this assignment, which is basically I'm giving you 2 more yield monitor raw data from that same field, but different years. So the one that we worked in class was for 2017. I'm giving you now 2019 and 2020. If you go again so this is the folder that is associated with the GitHub repo. If you go on the 03 data folder, there is now so before we worked with yield 17, now there is one yield 19 and one yield 20. Again, the same type of data, just different years. And I believe they're all for cotton as well. So the yield 17 was cotton in 2017, and then the 19 and 20 are also cotton yield monitor data. So here's the assignment. In class, we did the wrangling and yield monitor filters for the 2017 data. Now, what I want you to do is basically apply the same scripts, or not the same scripts, but the same concepts to these 2 new yield monitor data files. So as part of the assignment, you're going to have to wrangle and clean each one of these 2. So we have to do twice, right? For one for each of the 2019 and then 2020. So wrangle and clean just like we did in class. What your answers are basically going to be just what you share with me is basically the statistical summary of the clean version. So including minimum, mean, maximum, SD, and coefficient of variation, which you're going to include here as answers to these questions. So this QMD file is what you're going to answer, render, and send to me. However, it is really important that you do this, and the reason is that in the end, you will be exporting the yield 17 clean and the yield 20 clean, which are what we just exported today for the yield 17, right? So after going through all of the wrangling and editing, in the end, we did export the clean version, what we just did today. You will have to do this for the 19 and 20 on your side. You don't have to share with me the files, but you will have to have them, because in a few class periods, you're going to have to use those generated files. And if you don't generate on your side, I'm not sharing them with you because you can do that. So you have to do that on your side so we can keep going in the future, right? So just to pave the way a little bit more, we took 2017, we wrangled and edited the file and then exported the clean version. I want you to do again for the 2019 and the 2020. So in the end, we're going to have the clean version of the 3 years, because in the coming exercise, we're combining all 3 years into one layer that we're going to talk more later. But again, you will have to do this on your side. And the thing is, you know, as you're noticing, my assignments to you are not heavy, right? I mean, you have the code, you just have to adapt it. You have to think about how you can adapt to the new data sets, but you pretty much have the code already written because this is what we did in class. You have to do some small tweaks, but the majority of it is ready already. It's just adapting. So my assignments are not heavy, asking you to do something that you have to do from scratch. However, because of the nature that like we're developing a layer today that we're going to be using tomorrow, I cannot give you a lot of time to complete it, unfortunately, because I do require you to finish the assignment so we can use those layers in the coming classes. So because of that, unfortunately, my deadline for you is Tuesday, 11:59 p.m. to do this, which is tomorrow, right? So not a lot of time, but you have the scripts ready. You just have to adapt them to the new data sets. And what I do encourage you to do is take the scripts that we finished, so that we worked in class, copy them and paste. So create another copy of that same script, and then rename it to mean something related to the data set that you're going to be working with, right? So let's say, so we have the yield 17 wrangling and editor QMD files. You can just copy and paste them and just rename for yield 19 wrangling and yield 19 editor, and do the same for the 20. So the code that we did in class, you don't touch it. You leave it as it is, and you're just creating new scripts to now do the same steps for new data sets. Yeah, I think that's all I had for you as far as the assignment goes. And again, if you have any questions, post that on GitHub. I'm really, and I just want to, I guess, remind you all of something. Class participation is important. It's part of your grade. Yeah, I know that, you know, some people don't like to speak up in class, and that's completely fine. We do have GitHub for that, right? So if you participate on GitHub, either by asking questions, but especially by helping others, this counts towards your participation as well. So even if if you don't like to speak in class, make sure you're doing something on GitHub to get those participation points, because they do count, right? So during the mini project, during the assignment, if you have any questions or code questions or something like that, use GitHub, because as you may have seen, like sometimes a student asks something and I don't answer right away. Another student comes in and helps, and that's great. That's really what I want to use GitHub for, is that you can all help each other as well.
Did you want to do an attendance for today on GitHub?
Yes, I was getting to that. Before I got to that, I just want to say, so I just want to finalize here saying, well, as far as the assignment, it is due tomorrow, so very short deadline. You have to do the wrangling and editing steps for 2 new data sets. I have already uploaded all that to GitHub. So we already have the 2 new data sets to the 03 class code folder. Let me pull that up again, just to show again. So this is, again, the GitHub folder that you're going to be, that maybe already downloaded. So we have on 03 data, the 2 new data sets, yield 19 and 20. On the assignments folder, we have assignment 5, which is the one that has all the instructions I just showed you and the questions that you'll be submitting to me by tomorrow, 11:59 p.m. And you should have everything you need to complete the assignment. Does anyone have any questions about the assignment?
Dr. Bastos, we are using the same criteria for the filtering, right? I mean, those quantities that we use for filtering.
Yes, yeah, absolutely. Yeah, it's just the data that's changing, right? But everything else is already as we developed in class. Yeah, and again, maybe you will need to do some adaptation of the code, especially when it comes to column names, right? Because now these are 2 new data sets. These data sets may have already been played with by other people before they got to me. So there's going to be some changes that you're going to have to think about how to incorporate especially in the wrangling steps. But after you do incorporate them, then everything should be quite the same as we did in class. Okay, any more questions about the assignment? All right, I don't hear anything, so I'm gonna assume that we're all good. And now, thanks for reminding me about the GitHub attendance. I normally want to do that in class, and sometimes, perhaps a lot of times, I forget. So thanks for the reminder. I'm gonna go ahead and do that right now. Okay, so I just created the issue. Please go ahead. And since we're doing this in class, I will not accept answers after class, right? If I do forget to create the issue, then I do give you more time to answer. But since we're doing in class, please go ahead and answer while we're still in class. Okay, so while you're all answering to the attendance, I mean, we don't have a lot of time left, so I don't want to just start the interpolation exercise today. We can start that on Wednesday. I'm pretty confident we're going to be able to finish that on Wednesday as well. So yeah, it's gonna be important that you finish the assignment by Tuesday, because then we may start using the data, the clean data that you generate right there on Wednesday as well. But I'll keep you posted. All right. Any so I'm trying to enter your grades and attendance as we go on ELC. If you see any discrepancies, if you think there's something wrong, please let me know. I do make mistakes. I try not to, but I can. So if there's something wrong, bring to my attention and we'll address it. And other than that, if someone has code issues that you would like to troubleshoot, I have some time available now after class. So feel free to shoot me an email and I'll send you a Zoom link for us to connect. And if not, I'll always, again, use GitHub as your resource. Google is your friend always. ChatGPT can be your friend as well, even though, I don't want you to create your answers from it, but you can learn from it for sure. Yeah, let me know if you have any questions.
Professor.
Yes.
Yeah, I have like small questions.
Mm-hmm.
On the maps we developed, can you estimate the area of the field from there because you have the points, or you have to do something like different? Is it possible to estimate the area from there?
You mean the area of the entire field?
Yeah.
Yes. So the way that we would do that, it would basically have to be using one of the polygons. So either the field boundary or the so we also, because if you remember, we had the field boundary, but we also did the negative buffer, which was also a polygon. So you could use either of them if you wanted, and it's actually pretty straightforward. Let me pull that up here and show you. So this is not part of the class necessarily, right? I mean, it's not something that we did in class or I'm going to ask you to do. I just want to show you how you would do that. So we have the object boundary W, which if I just print here is our, well, and I just want to say, I mean, if you want to stay, if everyone else wants to stay to see this, you're welcome to, but you don't have to. This is not part of the class content. So Dennis, again, one important thing is to make sure it is projected, right? So which is, and then there is a function, I just want to use a pipe here to connect. There's a function called st_area that comes from the SF package. That basically, that's it. So it gives you already in square meters. You know, if you want to transform from here, you can do different transformations, but this field based on the boundary of the field is 400,000 square meters.
Okay, thank you.
Yeah. All right, I think we're good for today. If you all have any trouble, send me an email or post on GitHub. And other than that, I will see you Wednesday.